Welcome to solverfy.
So here we have an airplane propeller, and we need to find the kinetic energy, the rotational kinetic energy. So we have some givens: the length of 2.08 meters. We have a mass of 117 kilograms. We have an initial, rather just an angular velocity constant, 2,400 RPM, revolutions per minute. And we're going to multiply this by 2 pi radians per revolution times 1 minute for every 60 seconds. And this will give us 251.333 radians per second. And at this point, we can find A. So kinetic energy rotational is going to equal half times the moment of inertia times omega squared. For the propeller, we can have I for a slender rod, and the axis is through the center. So this is going to equal ml squared over 12. So the kinetic energy rotational is going to equal 1 over 2 times I, which is ml squared. So it'll be ml squared omega squared over 24. And this will be 117 kilograms, 2.08 squared, 251.333 squared, all over 24. And this is going to give us 1.332 times 10 to the 6 joules. Now, in part B, they're asking us the mass, the new mass has to be 75% of the old mass. However, the kinetic energy must not be changed. So what's the new angular velocity? So this would equal 87.75 kilograms. And we can just say kinetic energy rotational equals, we can go back and say ml squared omega squared over 24. And at this point, we have to solve for omega. So omega will equal 24 times the kinetic energy rotational divided by ml squared. And this will all be to the half power. So at this point, we can then solve and say that omega is equal to 24 times 1.332 times 10 to the 6th all over m, which is going to be 87.75 times L, so 2.08 squared, all to the half power. And we find that this is going to equal 2.771 times 10 to the 3rd RPM, revolutions, rather radians per second. And this will be your answer for part B. And that's the end of the solution. Thank you for watching.